Hi, Justin.
It's Jeffrey.
I'm sorry, Jeffrey.
To that.
How you doing?
Doing well. How are you?
Peachy keen, wonderful. Just happy to be here. Make sure I get you marked in here, all right?
Sounds good.
All right, Jeffrey. That's the 16th, yes. Okay, how we doing, guys? Davila, you doing okay? She doesn't want to talk. She's chatting, but she doesn't want to talk.
Yeah, I'm doing good. How are you?
Peachy keen, wonderful. Just happy to be here.
Right.
Anybody do anything stupid like study chemistry over break?
No, I did the lab like the day before it was due, I think.
Okay. Any problems with it?
1 through 18 was kind of easy, but then like when we got to like 19 and 20, it kind of got hard, but then like a lot of the problems were the same, just different like letters and stuff, like different chemicals. So it got like, once you get like one of the problems, and the rest should be easy.
Once you pay attention to what he's doing, and the whole thing about it, he thinks this is like a marathon in many occasions. And so once you get into that mindset, then you can generally do okay with it. All right, guys, we're doing moles. For the people in my lecture, I really am sorry we're doing this now as opposed to like the week before the test, but that's just the way the scheduling goes sometimes, and I apologize for that. Other than that, anybody have any questions for me? Okay, with that in mind, I kind of like work this as like a workshop. Generally speaking, if you've looked through the problems, you generally figure out that they're set up as sets. There are almost like 4 sets of 2, in which there are 4 questions, in which the second question is real close to the first one. Okay, and basically what we're doing is we're converting from moles to molecules, atoms to molecular weight, atomic weight. If I were going to tell you something you're going to need, I would concentrate on going from moles to weight and from weight to moles. That is what you're going to need specifically in the next couple weeks, at least from the schedule that I have. Okay, everybody's seeing the screen, right?
Yes, sir.
Yes.
Okay, are you seeing? Yeah, you're seeing me. Guys, I'm still not feeling 100% here, so I may just go ahead and flick off the video, because what happens is I'm going to have to get up and walk around. So if that happens, please don't be disconcerted by it. Okay, Miriam.
Yes.
All right. Let's see, I'm going to get rid of this. There's a question I have. How many eggs are there, Miriam? Do the quick one. Don't do the... How many eggs are there? Come on, Miriam. This is not the hardest question I'm going to ask.
I think I said 60.
Okay. Put it in another way.
Like 10 times 6. I mean, each carton has 12 eggs. It's a dozen.
A dozen. Thank you. There are how many dozen?
5.
5 dozens, right? Each dozen is 12 per dozen. So if we're figuring out, if we want to know how many actual eggs there are, all we got to do is figure out a dimensional analysis problem. Figure out what we want to know. Put that on the right side of the equal sign and figure out what we're starting with. Then we got to put a conversion in there. How do we convert from eggs to dozens, or from dozens to eggs? We put the eggs on top because that's what we want. We put the dozen on the bottom because that's what we want to get rid of. In this case, there are 12 eggs to a dozen, so obviously 60 eggs. Sophia,
Yes, sir.
how much paper do I have there?
5 papers. Or
Five,
like 5 reams.
5 reams. Okay. Again, similar circumstance. I've got 5 reams. So how many sheets are in a ream? Anybody?
I think it depends.
500.
500. It doesn't depend, Jeff. 500 sheets in a ream.
Oh, I see.
Okay. So if I want to know how many sheets and I know I have 5 reams, then my conversion is going to be sheets over ream. And I know there are 500 sheets in one ream. Multiply that by the 5 reams, I got 2,500 sheets. All we're doing tonight, all we're ever doing in any mole problem is a simple dimensional analysis problem. We got to figure out what we want. We got to figure out how much we're starting. And then in between that, we got to put in a conversion factor with the label of what we want on top and what we want to get rid of on the bottom. Does this make sense, guys?
Yes.
So 1 dozen is 12 anythings. I could convert any number into a dozen. If I have 144 chocolate chip cookies, this means I have 12 dozen of them. 1 ream is 500 anythings. If I have 2,000 golden retrievers, this means I have 4 reams of golden retrievers. They're counting number, guys. We use them to make life simple for us. So, sorry. I'm trying to figure out where I need to be in this slideshow. All right, there we go. Avogadro, the famous guy that the number is named after, has nothing to do with the number. Basically, what Avogadro came up with was he hypothesized that the number of atoms of gas are directly related to the volume of that gas. That's all he came up with. Little later on, a guy by the name of Proust used the standard oxygen. And he already knew that oxygen had 8 neutrons and 8 electrons. He knew that oxygen was diatomic. So in measuring oxygen gas, he had to account for each molecule being 16 protons and 16 neutrons. He suggested if we count the neutrons as 1 and the protons as 1, we would have 32 grams of oxygen. Now, they were able at this point to weigh a proton and neutron and found that it weighed 1.67 times e to the 24th grams. So if we know that each proton or neutron weighs that, can we find out how many molecules there are in 32 grams of oxygen? Very easy, guys. We had 32 protons and neutrons. They each weigh 1.67 e to the 24th. So if I have 1 molecule, it actually weighs 32 times 1.67 times e to the 24th. This gives me 5.344 e to the 23rd actual mass of 1 molecule of oxygen. So if we have 32 grams, this means that 1 molecule divided by the weight per molecule gives us 6.022 times 10 to the 23rd. Molecules. And this is basically where that number came from. Now, problem was O2 is complicated. First of all, it's a molecule. Second of all, it's very, very reactive. So chemists decided they were going to go with carbon instead. So with 6 neutrons and 6 protons, we have an atomic weight of 12.00 for carbon 12. And what we're going to do is we are going to relate each and every other element to carbon 12. So if we have 12 grams, going through the similar math that we did for the oxygen, we end up with 6.022 e to the 23rd atoms of carbon. Now we just got to designate that large number as something. We decided, okay, we're going to call that large number a mole. If we have that many of anything, we have a mole. So 1 mole is equal to 6.022 times 10 to the 23rd atoms or molecule. The 6.022 e to the 23rd atoms or molecule are equal to the atomic or molecular mass, depending upon whether we're dealing with an element or a compound. And the atomic or molecular mass is equal to 1 mole. Understand, in all this value, 1 mole is not changing. Avogadro's number is not changing. The only thing that's going to change is going to be the atomic or molecular mass based upon what the element or what the substance is. So, as I said, we're going to use simple dimensional analysis. If you want moles and you have 45 grams of H2, put what you know on the left side, you're going to multiply that by a conversion, and that's going to equal what you want. This problem, I want moles. It goes on the right side. I have 45 grams of H2. I got to put a conversion factor in between it. I want to end up with moles, and I want to get rid of grams. So I have moles over grams. All right, now I got to figure out the relationship between moles and grams. And I know from my handy dandy little chart here, 1 mole is equal to the atomic or molecular mass. It's H2. The molecular mass of H2 is 2 times 1.8008. This gives me 2.016 grams of H2. That is equal to 1 mole. So I put the 2.016 on top. Put the 1 mole on top, the 2.016 on the bottom, and do the math out. I end up with 22 moles. Do I have any questions from anybody? Fairly simple, guys?
Yes, sir.
Come on, guys. Any questions? Did you have your second test before the break?
I didn't.
You didn't, Jeff?
No, sir. It's Thursday.
Huh. So you have to do moles yet on here, right? So maybe this will help. Good.
No, I've already done moles.
Oh. Okay.
Yeah.
Anybody having any problems with this? You're given 3.29 moles of naphthalene. How many molecules it is? Is there a direct relationship between moles and molecules? Miriam?
I don't know.
Sophia?
What was the question?
Is there a direct relationship with moles and molecules?
They can be proportional. I guess.
Absolutely. Do we have any kind of relationship between 1 mole and any number of molecules?
Yes.
What is that, Victoria?
6.022 times 10 to the 23rd equals 1 mole. So you
So-
would do 3 point, never mind, sorry.
Sorry. So I have a direct relationship between moles and molecules. So I have that 1 mole is equal to, as Victoria says, 6.022 e to the 23rd. My known is 3.2 moles. What I want is molecules. So my conversion is what, Miriam? If I want molecules and I want to get rid of moles, what goes on top, molecules or moles?
Moles.
Okay, if I multiply moles times moles over molecule, I get moles squared over molecules.
Well, you need them to cross out, so it'll be
What goes
Mole.
on top?
molecules.
Molecules goes on top, and what goes on the bottom then?
The moles, so they cross each other out.
Absolutely. We want to get rid of moles. So molecules goes on top, moles goes on the bottom. All we got to do then is plug in the number. So we have 3.29 times 6.022 e to the 23rd. That gives me 1.98 e to the 24th molecules. $50 million question. 5 points on the next exam. If you have 3.29 moles of benzene, how many molecules of benzene do you have? Two.
What was the number?
You have 3.29 moles of benzene. How many molecules do you have? 4, 5, 6,
I have to do
7,
math. Hold on.
8,
6.022 times e to the 23rd.
9. What is the number?
Wouldn't it be 1.98?
Yes, exactly.
3/4?
Exactly. It's the same numbers we have. It doesn't matter. It doesn't matter if we're talking naphthalene or benzene. 3.29 moles is going to give you the same number of molecules because the ratio doesn't change. So 3.29 moles of benzene is just like it was for naphthalene, 1.98 e to the 24th molecules of benzene. They weigh differently, but the number of molecules is the same. All right, new question. How much does 7.54 e to the 24th molecules of sodium sulfate weigh? Jennifer, is there a relationship between the numbers of molecules and the weight of sodium sulfate?
Yes.
What is that relationship?
That relationship is the molecular weight equals how many molecules there is.
The molecular weight equals how many molecules there are. Okay, so, all right, I figure out what the molecular weight of sodium sulfate is. Sodium is 22.99. I have 2 of them, so I got to multiply that by 2. Got 1 sulfur, multiply that by 3206. I got 4 oxygen, so I multiply that by 16. Add that all up, and I get 142.04. So if I have 142.04 grams of sodium sulfate, that means I have, by the way, I'm stopping the video now, guys, because I'm getting a little antsy. If I have 142.04 grams of sodium sulfate, this means I have 6.022 e to the 23rd molecules. Again, dimensional analysis. I got the molecules, that equals number of grams. I want grams, so grams goes on top, molecules goes on the bottom. That ratio is 142.04 to 6.022 e to the 23rd. I do that dimensional analysis out, and I end up with 1,780 grams. Questions, guys? Gaith, are you in here? Davila's here. Monica, are you in here?
Yes, but don't ask me, skip me.
Apple Grace. Apple Grace?
I'm here.
Hunter. Hunter?
Yo, what's up?
Leandre. Leandre? Maverick.
Here.
Tyler.
Yes, sir.
I saw. Jeff, I got. Grace.
Here.
Katie.
I'm here.
Mateo.
Yes, I'm here.
Faith.
Here.
Faith. Jennifer, I saw you. Victoria, I saw. Michael.
Here.
Philip, I saw. And Miriam, I got. Okay, ladies and gentlemen. Are these problems that hard, guys? Really and truly. They're not that hard,
No.
are they?
No.
Okay. All right. What I did was I did 3 of the 6 types of problems. I went from grams to moles, but I could just as easily have gone from moles to grams. By doing that, all I have to do is invert the conversion factor. I went from moles to molecules, but I could go from molecules to moles again by inverting that conversion factor. I can go from molecules to grams, but again, I could go from grams to molecules just by inverting the conversion. Understand, I've been using molecules this whole time, but I can use the same rules for atoms. The only thing different is the definition. If I'm dealing with an element, instead of calling the particles molecules, I'm going to call them atoms. Instead of calling the weight the molecular weight, I'm going to call it the atomic weight. Harder problem. I got 23.5 grams of ammonium phosphate. How many atoms of hydrogen are there? Okay, guys, you said these were simple problems. How are we going to go about this?
You have to find the molecular weight of the
Okay.
compound.
I find the molecular weight. What's that going to give me, Victoria?
Oh, that's a lot of math I gotta do, so you
No,
gotta
no,
hold
what
on
it-
a second.
all right, just in general, if I have the molecular weight, what is that going to give me?
The grams, the total weight of the compound. But then you could do 23.5 grams over whatever the molecular weight of that is to cross it out. Am I going like too far with this?
Yes. Yes.
Sorry. Someone who's
Where do you want
has
to
a
be?
more simple answer.
Where do you
I
want
wanna
to be?
I want to get to atoms.
Okay, so what are you going to have to use eventually? What number, what value are you going to have to put somewhere in this equation at some point?
Avogadro's number.
Avogadro's number, okay? But the point is, I don't have grams of hydrogen, do I? Victoria?
Well, no, you don't.
No, I don't. So I'm going to have to find out what first.
Don't you have to just take hydrogen out and see how, like you do 1.008 times 3 to get the weight of hydrogen? Since there's 3 hydrogens.
There are 12 hydrogens.
Sorry, that 4 threw me off. There's 12 hydrogens.
What, are you suggesting do the mass percent?
No, because that's a totally different thing.
I was gonna do that the percent way.
You can do it, Tyler. That is one way to do this. Hold on a second and I'll show you. You're absolutely right. You can. I don't want you to go there at this point though. Come on, guys. Think. How are we going to do this problem?
Find the atomic mass or the atomic weight and then use that.
But I don't, Maverick, I don't have the atomic, I don't have the grams of hydrogen. I have the grams of this compound.
Wouldn't the grams of hydrogen be whatever the atomic weight is of hydrogen times 12?
No, that just, the atomic weight of hydrogen times 12, that would just give me the the contribution of hydrogen to that entire ammonium phosphate compound. Come on, guys, what do I want? Where am I going with this?
You would probably need the molecular weight of the compound in its
Okay.
entirety.
All right, I need
It's
the
not-
molecular weight. Victoria already did that. Okay, we have the molecular weight. What are we going to make the molecular weight equal to?
A mole.
Okay, that would give us moles of ammonium phosphate.
Yeah.
If we take 23.5 grams and multiply it by 1 mole over the molecular weight, that would give us moles of ammonium phosphate. All right, where do we go from moles of ammonium phosphate?
Then you could, then you would go from moles to,
Molecules, right? And
Okay,
then molecules to atoms.
yeah.
okay. I now have moles of ammonium phosphate. I'm going to multiply it by Avogadro's number of molecules over 1 mole to get the molecules of ammonium phosphate. Now what do I do?
Now would you start doing the individual weight of hydrogen? Like, what is
Nope.
this where you?
I don't want to know. I don't want to know weight. I want to know atoms. Do I have a relationship between the number of atoms of hydrogen in every one molecule of ammonium phosphate?
Yeah,
You know,
Who said yeah? What is that ratio?
12 to 1.
12 to 1, guys. So the whole strategy here, I'm going to go from grams. As you guys said, I can multiply that by 1 mole over the molecular weight of ammonium phosphate. That would give me moles of ammonium phosphate. I then take the moles of ammonium phosphate, multiply that by Avogadro's number over 1 mole. This gives me molecules of ammonium phosphate. I then multiply this by 12 atoms of hydrogen in 1 mole of ammonium phosphate. So again, first step, I am going to figure out how many molecules of ammonium phosphate I have. I do that by figuring out my molecular mass. For nitrogens, oh crap, I did this wrong. Okay, we're just going to go with my bad numbers here. This should be 3 nitrogens. I'm sorry, that was my fault.
It should be 42.03 for the. Got it.
Sorry. $42.03, right?
Yeah.
And so somebody subtract 14.01 from 163.
Okay.
149.1.
Thank you. All right. So that is my molecular weight for my ammonium phosphate. Okay, so I've got grams. I want molecules. So guys, yeah, you are perfectly right. You can do it 1 mole over the molecular weight and then multiply Avogadro's number over 1 mole. But you can also put Avogadro's number over the molecular weight, and that would also work. So I do that. And did somebody do the math for me yet?
I'm working on it.
Working on it.
It should be 9.49 to the 22nd.
22nd. Yeah.
Okay.
Or times 10 to the 22nd, I should say.
Perfectly good. So now I've got the molecules of ammonium phosphate. All I got to do is multiply that number by 12 atoms of hydrogen. And
So like, if I did it right, yeah, like 1.14
1.14
yeah,
to the 25th.
I got
24th.
to the 24th.
24th.
Yeah.
Okay. That was a harder problem, guys. That's about as hard as they're going to get. Main thing right now, you should really, really concentrate on being able to turn grams into moles and moles into grams, because we're coming up, we're going to be doing empirical formulas and we're going to be doing stoichiometry. Both of those require that you use moles. So you got to be able, you got to be facile at being able to convert these things. All right. What I'm going to do now is I'm going to go over about 5 of the 8 problems. Or rather, we're going to do them together. All right. You got 143 grams of copper sulfate 5 hydrate. I want to know moles. So I have 143. What do I know?
You have 143 grams of copper sulfate with 5 water.
Okay, I have 143 grams. What do I want to know?
I wasn't looking at the question. Sorry.
Moles.
I
Thank
want
you.
to know moles. Okay, so what's going to go on top and what's
Moles.
going to go on the bottom?
Moles is going to go on top. Grams is going to go on bottom.
Okay,
Grams be the molecular weight.
grams are going to be the molecular weight. And what's going to be, who answered that, Jennifer? What's the number going to be in front of moles?
1.
So 1 mole is going to be equal to the molecular weight. And, oh, crap. Copper, sulfur, plus plus 5 times 18.02. 18.02 is water. And I think that turns out to be 342 point something.
18 times 5?
No, the whole thing.
Oh.
Maybe wrong about that. I got 249.71.
Yes, sir.
So guys, at this point, all I got to do is plug that into the formula. I get 143 grams times 1 mole over 249.71 grams. All I got to do is divide the 143 divided by 249.71, and this gives me
0.5726, whatever, however you want to round it.
73. Sig figs, Victoria. 3 sig figs. Answer.
Yep.
3 sig figs. All right, so I have 0.573 moles. Second question it asked me, how many molecules is this?
You know that a molecule is Avogadro's number.
Okay, tell me what to do, exactly what to do.
So you've got just over half a mole there. So what you could do is multiply that number times, it'll be Avogadro's number divided by 1 mole. And you missed a 2 there, if that's gonna bother you.
No, it doesn't bother me.
All right.
This has 3 sig figs, so it's not gonna.
I got like 3.45 E23.
I got 347.
And
I got 345 as well.
Did you do 6.022?
yeah.
Yes.
That's why. Okay. All right. Now, do we have a relationship between number of atoms to number of
Yeah.
molecules?
Yes.
Yes.
What is that relationship?
When you just take the coefficients, the sum of the coefficients, right?
Coefficients, Victoria?
No, because you're giving me that tone.
Yep.
It's the sum of something.
Subscripts. Okay, you got to get the total number of atoms. I got 5 waters. So water's contribution is 5 times 2 for 10, 5 times 1 for 5. 10 plus 5, 15 from the waters, plus 4, 19, plus 1, 20, plus 1 from the copper, 21. There are 21.
So you would do that times 21 and you should get with sig figs 7.29 e to the 24th. Maybe.
What'd you say it was, Victoria? I'll trust you on it.
7.29 e24 because I'm rounding to 3 sig figs. Someone can double check if they want.
Yeah, that's right.
Okay.
Okay, guys. I have all the confidence in the world that Tori, Jeffrey, Maverick seems to know what he's doing, and Jennifer know what you're doing. I have absolutely zero confidence in the rest of you because you're not answering any questions. So thank you very much, guys. The guys that have been answering, you're doing totally great work. But I'm sorry, I need to hear from the other faction. We have problem number 2. We have 42.68 grams of sucrose. We just did this same problem. Exactly. 42.68 grams of sucrose. I don't want to call on anybody, but by the same token, I'm not going to sit here in blank space forever.
I have a question.
Okay, good, please.
So for this problem, so would you go to the periodic table and find the grams for like the C12, H22, O11, and you add them together? And then that's the grams?
That's the molecular weight, exactly. But you have to understand, Miriam.
Mhm.
Say the atomic weight of carbon is 12.01. How are you going to get carbon's contribution? What are you going to do with it to the molecular weight of sucrose?
So the 42.68 would be, so you'd multiply that and then the grams of
No, let's be specific, Miriam. What are we multiplying the 4268 by?
The average, whatever number.
I want moles first.
Oh.
Okay, that's the first question. How many moles do I have? Okay, guys, let's set up the problem. What are we given? What does the problem give us?
So you'd start with the 42.68 grams, right?
That's what we know. What do we want?
Moles. So the moles would be on top.
Moles are on top, grams are on the bottom.
Yeah.
What's the relationship between moles and grams?
I don't know.
What is 1 mole equal to, Miriam?
I also don't know.
Okay, somebody help her, please.
It's the molecular weight of the compound.
So Miriam, you were right. We need to get the atomic weights of each, the carbon, the hydrogen, and the oxygen. And we have to multiply those atomic weights by the subscripts you see there. That will be the contribution. For carbon, we multiply 12 times its atomic weight. That's carbon's contribution. For hydrogen, we multiply 22 times its atomic weight. For oxygen, we multiply 11 times its atomic weight. And we do all that math out.
Okay.
And it ends up being about 342.
So you do 42.68 grams times 1 mole over whatever the weight. Okay. And so that would just give you the moles. That's all you'd have to do for the first part of the question, right?
Yep.
Okay.
And that comes out to 0.125 moles.
Okay. Now we have 0.125 moles. The second part of the question asks us for molecules. Thank you, Miriam. Jennifer.
Yes.
Okay, I've got moles and I want to go to molecules.
Okay.
So what's going to go on top?
6.02 times e to the 23rd molecules.
And on bottom?
1 mole.
And this gives us 7.51 e to the 22nd.
Oh, I put the wrong number in.
Slap yourself.
I need to do that.
All right, now, remember what we did the last time. We now have the molecules of sucrose. How are we going to get the atoms? I want the total atoms. How many atoms are in there, one molecule?
Use the Avo. I don't even know.
No, we've
gotta
already
take-
used Avogadros.
You gotta take the subscript, right? To get the atoms.
Take the
Yay.
subscripts.
I got it right this time. Woo!
I have in every sucrose molecule, I have 12 carbons, 22 hydrogens, and 11 oxygens. 12 plus 22 is 34 plus 11. There are 45 atoms for every one molecule. So I am going to take my 7.51 e to the 22nd and multiply that by 45 atoms per molecule.
You should get 3.39 E24.
Questions, ladies and gentlemen?
How did you get 45 atoms again?
Okay,
You added the subscripts?
yeah, because each molecule of sucrose has 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen.
Okay, I understand. It's not to get it.
So as long as we have provided one of those, we can get the answer to any of them.
Huh?
Like as long as we have the moles of something or the molecules or the atoms, we can find out through the inverse relationships what the other is.
Okay, are you asking, Hunter? If you have 3.39 e to the 24th atoms of atoms within sucrose, how many molecules of sucrose do you have?
No, I'm just simply stating that if you have a given information about that, you can kind of backtrack to get whatever else
Give
information.
me an example. Give me an example, Hunter.
Like, okay, if you have 3.39 e 24 atoms, you could backtrack to get the molecules by just doing the opposite of what we did to get the atoms in the first place.
By taking the inverse of the conversion.
Yeah.
So in that case, instead of multiplying by 45 atoms over molecules, I'd be multiplying by one molecule over 45 atoms.
Okay.
All right, does that make sense now?
Yeah, for sure.
All right. Are we good with this, guys?
Yes, sir.
Yes.
Yes.
All right. Problem 3. Okay, there is a typo. There is a typo in the data table for this particular lab. The laboratory reads molecular mass is equal to mass divided by moles. We're dealing with an element. That typo should say atomic mass. Okay, it's a semantic thing. I realize, guys, it's a semantic thing, but it's an important one because we have now changed. We're dealing with an element now. The reason that's important is because we're dealing with elements, and elements use atoms, not molecules. Okay, we're dealing with something that has 4.384 moles and it weighs 240.7 grams. What is the atomic mass? We've already been told. The atomic mass is equal to mass divided by mole. So simply speaking, guys, all I got to do is take the 240.7 grams and divide it by 4.384. If you want to understand the logic behind that, the label for atomic mass is grams per 1 mole. If 4.384 moles weighs this much, then in order to get how much 1 mole weighs, you got to divide the 240.7 by the 4.384. Does that make sense, guys?
Yeah.
So if it's asking, if this problem is asking like what the element this is, you would just do that, and then that would be like, for this one, it'd be manganese.
I'm sorry. I believe you're right. I'm sorry, Katie, but it has been, as I said at the beginning of class, it's been a good 3 years since I've taught this class.
Okay.
Okay. So literally speaking, I can't tell you directly it's manganese, but it sounds about right. Okay.
It has the same atomic weight.
All right.
I did it too, Katie. It's manganese. You're good.
Okay.
All right. Basically, guys, what you are doing is you are dividing the mass of the substance by the moles. You do that math out. That is the atomic weight. Then what you do is you search your periodic table for a atomic weight that is similar. So right now, 240.7 divided by 4.384, that gives me 54.90. I look in the periodic table, and that's pretty close to 54.94, which is manganese. Okay, so that's how you're supposed to do the first part of problem 3. Okay. Now, I want to know how many total atoms. Somebody come up with a suggestion. Can you hear me? Hunter, shake your head. Okay.
No, do you want it empirically or the molecular?
I want to know how many total atoms.
Okay, we'll take the mole and divide by the atomic mass divided by the 1 mole.
Is that right? Obviously, I'm questioning, Hunter. No, it's not right.
No,
okay. Go ahead.
I'm just looking at the slideshow.
I want to know how many total atoms I have. I got the weight, I've got the moles, and now I've got the atomic mass.
When you multiply, since 1 mole is 6.02 to the 23rd atoms, you'd multiply that number by the 4.384.
Very good. Who came up with that?
Jennifer.
Jennifer, you're absolutely correct. Remember, guys, I'm talking elements. So here, I don't have to multiply by atoms in a molecule because I have an element. If I have the moles, I'm going to multiply the moles directly by 6.022 times 10 to the 23rd atoms per mole. Moles cancel out, and I'm left with atoms. Okay. Problem 4, and I think I've only got 3 more of these that I'm going to go through. Maybe. It depends upon your patience and my hunger. I got 14 milliliters of a liquid that has a density of 0.8765. If this quantity also equals 0.157 moles, what's the mass of my substance? I'm pulling back information from probably the third week of class. You got 14.0 milliliters of a liquid with a density of 0.8765 grams per milliliter. The quantity also equals 0.157 moles. What is the mass?
It's
You would have to do
so I'm multiplying it
Density
divided by volume. Sorry, go ahead.
0.765.
Okay, somebody is
Density
talking
times-
and they're breaking up.
It's the density multiplied again, or by the liquid. Right, mass equals.
Simple
density
enough,
times
guys.
volume.
Again, this is chemistry. We don't forget anything.
It's the density times the volume. It's the
Yeah,
14
that's all it
times
is.
0.87, whatever.
Okay, we do this.
12.271. So if someone wants to double check.
12.3.
Yeah.
Okay. Now we want the molecular mass. Anybody remember how we got the molecular mass before when we had the moles and the grams? How do we get that?
It's 1 mole over molecular mass.
How do we get the molecular?
Yeah.
What?
Go ahead.
Well, I was saying that you need to figure out the mass. So
We got the mass, 12.3.
So
we got the number of moles, 0.157. So if the atomic mass is equal to the mass divided by moles, what is the molecular mass going to be? If the atomic mass is the mass of the element divided by the moles of the element, how are we going to figure out the molecular mass?
Times it?
If the atomic mass is equal to the mass of the element divided by the moles of the element, how are we going to figure out the molecular mass?
Divide the mass of the molecule by the moles of the molecule.
Thank you. Thank you. So I know that I have molecular mass is equal to grams divided by moles, which is equal to 12.3 divided by 0.157.
That doesn't 78.3. I don't, that doesn't feel right to me, but someone could double check.
It's right.
Okay.
I know what I was thinking of, so I know what it is. Okay, so this is the molecular mass. Next question. How many molecules do I have?
So would you take the number that you just had and times it by Avogadro's number?
Nope, because that.
Never mind.
That is, that the number I just gave you is equal to Avogadro's number of molecules.
Would you divide the mass of the sample by the mass of the molecule?
How do you know the mass of the molecule?
Oh, that's the molecular mass right there. The grams divided by the moles. Is it
That's the
not?
molecular mass. It's not the mass. I'm sorry. You said mass of the molecule when you should have said molecular mass.
Sorry.
No, it's fine. It's just, this is the molecular mass. If I divide this by this, I'll get 0.157. That's moles. I want molecules, guys. How am I going to get molecules?
Would you multiply 0.157 by Avogadro's number?
Jennifer, you keep on coming up with that, and you're right every time you say it.
Thank you.
Guys, we have moles, right? We have moles and we want molecules. So we got to figure out that we're going to put molecules over moles, and that relationship is 6.02 e to the 23rd molecules over 1 mole. Okay?
9.73 E22.
Okay. All right, this is a little bit of a different problem. I got 1.14 moles. It has a mass of 52.63 and a density of 0.789. What's the volume?
You do, oh crap, I forgot it.
Mass divided by density.
Yeah.
Mass divided by density. So I'm going to take the 52.63 grams divided by 0.789 grams per milliliter. Okay? What is the molecular mass? How are we going to figure out the molecular? How did we do it before, guys? Atomic mass is equal to grams of the element divided by moles of the element. Molecular mass is equal to, tell me what the numbers are.
What, sorry, repeat that.
We said at the very beginning, atomic mass is equal to grams of the element divided by moles of the element.
So you would do 52.63 over 1.14 moles?
52.63 grams over 1.14 moles. That will give me my molecular mass. Now, how many molecules are present? Jennifer? Don't answer. How many molecules are present? Somebody other than Jennifer.
We could times it by Avogadro's.
Take what times, Hunter?
The molecular mass, so 46.1, 6666667 times Avogadro's number.
Okay.
Wouldn't you multiply the moles by Avogadro's number?
Yeah, Hunter, remember, the molecular mass is equal to Avogadro's number. Okay?
Oh, yeah.
So we have 1.14 moles. Okay? We could also do it. We could do it by your method. We could take the 52.63 grams and multiply that by 1 mole over the molecular mass, and then multiply it by 6.02 times 10 to the 23rd. Or we can do it directly. 1.14 moles times 6.02 times 10 to the 23rd. Anybody have any questions here, guys? Last problem. Now I'm doing what I've done. I don't know if you have noticed this or not, but 2 of the problems are really, really similar to one another, so I didn't bother doing an example of it. But what I've done for the others is I've given you an example of what we're doing. I've given you an example of the problem you have to work as homework going through it. The density for dichloromethane, Cl or C2Cl2. I want to fix something. C2Cl2 is 1.33 grams per milliliter. If I have 25.0 milliliters, what is my molecular mass? Different way to think about this, guys. is the only way to get molecular mass, taking the grams of your sample and dividing by the moles. Is that the only way you can get the molecular mass?
Didn't you just add it up off the periodic table?
Add it up directly off the periodic table. So I'm going to take 2 times 12 for 24 and 2 times 35.5 for 71. I'm going to add 71 and 24. My molecular mass of C2Cl2 is 95. Roughly speaking, I used very simple atomic weights. What's the mass of my sample?
Don't you have to take density and the volume?
Victoria, are you speaking again?
Yeah.
Okay.
Hi.
Victoria said, we have the density, we have the milliliters. So we are going to make the volume and multiply it by the density. That will give us our mass. Okay. We now have the mass of our sample. How many moles do we have? We calculated the mass. We know what the molecular weight is. How do we get the moles?
So, I'm going to get it wrong. Don't you do whatever mass we just got over the molecular weight of carbon chloride or whatever the compound was? You put 1 mole over it. So it'd be 33.25 grams times 1 mole over the molecular weight equals whatever moles we have. Did I make that too complicated?
Okay. Now, how many molecules do I have?
Multiply that by Avogadro's number.
Thank you very much.
Should give you 2.1, I think, E23.
And I think the last question is, how many total atoms?
Don't you times that by 4?
Yeah.
Should give you 8.4 E23.
8 point what?
8.4 E23.
Okay, guys. This is the best way for me to do this. It kind of keeps you somewhat interested, and it kind of keeps your minds fresh doing this. If you are sitting back, not doing anything, guys, you got to be thinking of this. If you're just sitting back trying to get this by osmosis, it's not going to work. You're going to need to do a lot of practice of this stuff, because in the problems that are coming up, you're going to have to be able to do those conversions like that so that you can spend your time thinking on things that you really need to think about. That's all I got for you tonight, guys.
Thank you.
Any questions for me?
The lesson after this, is that gonna be empirical or the stoichiometry?
Empirical comes before stoichiometry. I'm fairly certain.
Okay.
Any other questions, guys? Okay. Have a good night. I will see you next week then.
All right. Get some food.
Good
Bye.
night.
Have a good night.
Good night.
Night.
Thanks.
Night.
Good evening,
Bye-bye.
everyone.
Professor.
Maverick, you made it all the whole time.
Yep.
Okay, I recognize you as being Philip or Michael. Michael, hi.
Yeah, I just waited till the end of class. Sorry, I'm having trouble understanding a lot of the material that you're teaching, especially tonight.
Okay.
I don't mean to disrupt your.
No, Maverick, what you got? Maverick on? Okay. Okay, Michael.
Sorry to have a one-on-one.
No.
What time does the class usually end?
What's that?
I don't want to keep you past the required.
No, that's
time.
fine. Okay. Can you pinpoint where you're starting to lose me?
Jeez. I didn't even have it from the jump. I was trying to just write it down, and I've been trying to just look through it and kind of teach myself, look through the videos and
No,
whatnot.
that's fine. That's fine. First of all, Philip, organic chemist, type in organic chemist in moles. Google that, and you'll get a guy that's very, very slow, that talks very, very slowly, and he will get you through this, okay?
All right.
All right. Now, I'm going to share screen again, and I'm going to go back here.
Maybe just start at I guess I don't think it was even problem. Yeah, problem one maybe. And just
Okay.
get
Now,
understanding at least here.
all right. Do you see this slide, Michael?
Yes, sir.
There are three basic relationships that we have. There's a relationship between atoms or molecules and mole. 1 mole is equal to Avogadro's number of atoms or molecules. Okay?
Yes.
All right. Avogadro's number of atoms or molecules are equal to either the atomic or the molecular mass. And the third one we have is the atomic or the molecular mass is equal to 1 mole. These are the three tools we have to do these problems. Okay?
Understood.
All right. Michael, have you done the problems in the survivor guide?
I don't think I have.
Okay, we're looking at module 7. All right. I would strongly suggest that you go down module 7. They begin on page 10. Strongly suggest that you do those problems. Have you had your test on moles yet, Michael?
Yes.
Okay, I take it you didn't
No, I
do
haven't
too
had
well.
the- Sorry.
I'm sorry?
I haven't had the test on moles. Sorry. No, I
No,
haven't.
no problem.
Upcoming one.
These are fairly easy. Do you understand dimensional analysis problems?
I'm not sure which ones those are. Sorry.
Okay, 1 second.
I probably don't though.
Okay, I just stopped the video. All right. If you have 32 inches, can you tell me how many feet this is?
Okay, I was understanding where you were coming from with this.
Okay, so basically,
Part of
tell me what I'm doing here.
So you're taking 12. There's 12 inches in 1 foot, and so I would take 32 inches is equal to 12 inches per 1 foot. Is that how you were explaining?
Okay, Michael, if I do that, if I put 12 inches per 1 foot, I haven't canceled out feet. Do you see that? And I haven't canceled out inches. So I don't get this. My answer is not in feet, but my answer is in inches squared per foot. Do you see that, Michael?
Yeah, I just don't.
I'm multiplying inches by inches to get inches squared, and I'm dividing by feet. So that is my label. I can't do that. So if I have inches and I want to get feet, what has to go on top? What do I want?
Feet. You want
So
feet.
whatever I want is going to go on top.
Sure.
What I want to get rid of is going to go on the bottom. Make sense, Michael?
Yeah, I got that was like from the previous work we were doing.
All right. Now, once you've got the labels so that they're canceled out, all you do is plug in the numbers. 1 foot is equal to 12 inches. You do that, do the math out, and you end up with 2.7 feet, right?
Okay.
Does that make sense to you?
Yeah, another question I had was how you guys were plugging it into the to your calculator, or how you were plugging in like for like problem 1 part anything that involved the E, like when you were using operator.
Okay, do you have a button that says EE on your calculator?
Yeah, I do. I was thinking it was that one.
All right, now,
Okay.
is it kind of on the face of the calculator?
Yeah, it's well, it's above looks like a comma or something.
Okay, so therefore it's probably the second function.
Yeah.
All right, so what I want you to do now is I want you to type in 10 into your calculator, 10.
Mhm.
Second function, where that EE button is,
Okay.
then hit 2 equals.
1,000.
You sure you put 2 there?
Yeah, maybe could you see it on this? Oh. Are you seeing that?
You put 10, try this again, try it again.
Okay.
10,
10.
second function,
Second function.
EE,
EE.
2, then the equal sign.
I got an enter. It comes out with to 1,000.
I don't know, I can't see your calculator, so
Yeah, I don't.
you can use that EE button. Okay, let's try this.
I have a lot of problems with this calculator using parentheses for certain things. I noticed that.
That's why I'm telling you to use the EE button.
No, I am using the EE button, but it's like when it's plugged in, a lot of the times if I don't use parentheses for certain sections of the equation, it'll come out with a completely different number.
All right. Let's deal with the things I can deal with. Okay, Michael?
Okay.
All right. So if I have molecules and I want moles, okay?
Okay.
Then to convert molecules to moles, I have to use the conversion, right? What's going to go on top?
The moles.
Moles. What's going to go on the bottom?
Molecules.
So now all I got to do is figure out from that one page what the relationship is. And the relationship is 1 mole is equal to Avogadro's number. So for mole, I put 1. For the molecules, I put 6.02 e to the 23rd. Okay, Philip, Michael?
Yes, sir.
Is this making sense to you?
Yeah, that's making better sense to me. So I just have I kind of get nervous asking questions to Malachi. I don't want to hold people up too, but
Do not ever think that. Okay. If I want to go from moles to grams. Okay. Where's that cursor at? If I want to go from moles to grams, what's my label going to be? What's going to be on top?
grams.
And the bottom?
Moles.
Okay, now we got to look at our chart. Our chart up here. What's the relationship between moles and some sort of mass?
the atomic or molecular mass is equal to
Okay, say I'm talking about CO2. Do you know how to get the molecular mass of CO2?
That's the no, I do not. Sorry.
Okay, what you do when you have something like this, you make a little table. Okay, that's the table, your element, and you're looking at the formula. Your element has a carbon in it. There is one of them. The atomic weight of carbon is 12.01. So what you do is you take the number and multiply it by the atomic weight, and that will give you the contribution.
So you're taking that plus the oxygen or 2 oxygens.
Exactly. My oxygen, I have 2 of them. They're each 16.00. So the contribution is 32. So my total is going to be 44.01. So when I'm doing the second one, when I'm going from when I want to go from moles to grams, I'm going to take the grams being the molecular weight, the 44.01, that's equal to 1 mole. So I'll take the number of moles I have, multiply that by 44.01 over 1 mole. This will give me the grams. Okay?
All right, and more than likely your answer will turn out to be each of the atomic weights added together.
The atomic weights added together end up making the molecular weight.
That's the grams divided by the mole, which will be the molecular weight.
Yes.
Which
Grams divided by moles equals the molecular weight. Okay, Michael, when I'm going to make a suggestion, okay?
Yeah.
It's been a half an hour since I broke off with the other people. What I'm going to suggest to you is that you look at the organic tutor. It's the organic tutor, organic cabinet, organic tutor. Okay, look at that video. Just type in organic tutor, comma moles. Look through that video. Okay. I want you to look through module 7 of the survivor guide. Try to do some of the problems. If you're still having problems, give me a call on Thursday, okay?
Thank you, sir.
No, there's no problem. It's just I'm getting a little tired right now myself, Michael, and I'm losing my effectiveness, and I can tell I am, okay?
Thank you, sir, for your time.
No problem. I really want you to get this, Michael, okay? So please give me a call on Thursday if you're not getting it, all right?
Thank you.
All right. Do you have my phone number, Michael?
It's in the syllabus, I assume.
Take it down, 727-202-7275.
Okay.
All right?
Thank you.
All right, you take care now, Michael.
You too.